Yep.
Okay, good morning everyone. We're doing our presentation on algebra. That was our topic, and our standards are to create and explain patterns and algebraic relationships, and to create algebraic and geometric patterns using concrete objects or visual drawings. Example, rotate and shade geometric shapes.
Our objectives: for one, we explore how patterns occur in objects and designs. We identify and define tessellations, which is what our activity will be based on. Distinguish what shapes make and don't make tessellations and distinguish their properties as well, and also create geometric patterns.
Okay, so a little background information on algebraic patterns. In order to obtain a deep understanding of algebraic reasoning, both the students and teachers must be able to recognize patterns, whether they be in contextual problems, in growing geometric figures, and in repeating geometric figures. Thus, the key in understanding algebraic reasoning is to refrain from treating it as an isolated content strand, as it traditionally is, but rather as a strand of thinking and problem solving beginning in elementary school and extending throughout mathematics education.
So the building blocks of algebra is really patterns. So basically what I interpret this quote to be is that algebra is important not just in math, but everywhere. So learning patterns, you can find patterns in poems and social studies, like all kinds of patterns. So understanding that and building that early on helps to develop not only math, but other concepts as well. For patterns, the more experience students get with generating patterns from situations, they become able to recognize patterns easier and describing how they change. So whether it be in geometric shapes and colors, or repeating patterns or growing patterns. Observing patterns to recognize relationships through patterns, so obviously the relationships. Recognizing patterns helps us learn about and understand the world in which we live, because patterns are all around us. Like I said, they're in poems, they're in the tiles in the ceiling. Patterns are pretty much everywhere.
So who can tell me what they think algebra is? Dana.
A way to solve for a variable.
Okay.
Anybody else want to build on that? Mary?
Just when a specific letter or symbol has a value.
So how would you react if you were us and we got the topic algebra and we had to create a lesson plan for a kindergarten class on algebra? Do you think we teach kindergartners variables and solving for x and y?
Sure.
Where would you start?
Patterns.
Yes.
What kind of patterns?
Colors and shapes. The patterns like circle, triangle.
Repeating patterns. How many types of patterns are there?
2 times.
Repeating is one, and what's the other one?
Growing.
Good.
Correct. So we want to stress to you today that algebra is all about generalizing patterns. We want to recognize patterns. So in a kindergarten class, you start with recognizing A-B patterns, repeating patterns, and growing patterns. And it's important to start really early in order to develop a deep conceptual understanding of patterns that then goes into more of a variable type of algebra that everyone does in the later grades.
And because it's also about relationships, it also, algebra involves, greater than, less than, equal to, which also has to do with patterns and relationships, because, you're relating that 1 is smaller than 3, and the relationship between 5 and 10, all different numbers.
Therefore, some misconceptions that children may have with algebra is that they're not distinguishing between letters used as units of measure and variables. So example, 8m equals 8 meters. M doesn't always mean meters. M could mean anything that you set it up to be in the key. And
another is thinking letters always have one specific value. So let's say they have a problem one day where A equals 2. Whenever they see A, they'll assume that A will always be 2, no matter the context.
And also, lastly, A plus B can't equal A plus C, because, it's like if you see 5 plus 2 can't equal 5, and C must be different than B. but that's not necessarily the case. It all depends on what the variable stands for.
Right, they think that just because B and C are different letters, that they have to be different numbers. And also, rules are used to determine the value of a variable. So, for example, they'll apply the alphabet, so B equals 2 because B is the second letter, and stuff like that. They don't really understand that B can be any, variable, that number that you assign to the variable. Okay, so tessellations are basically copies of a shape that cover a surface and there are no gaps between them. So M.C. Escher was a famous artist who used this kind of tessellation and manipulated it, not just with shapes, but he used like animals, as you see here. He used cubes, he used all kinds of symbols and patterns and basically played with them to create basically. These are tessellations. They're more complex, but there are simple ones. So this is one of M.C. Escher's things also, but it also, we wanted to show you that it's not just a repeating of shapes, but it's also repeating colors. So it's, red, white, and also as well as the horses are repeating too.
Okay. So these are examples of how we can find tessellations or patterns in our daily lives. So the bricks and the honeycomb that the bees make. Who can give me another example maybe of a tessellation that they see in everyday life?
Think about your kitchen, think about building on stuff you see outside, like tiles, definitely. Anyone else?
What's the key thing from the last slide that constitutes as a pattern being a tessellation?
Pattern of color?
No gaps.
No gaps. Definitely we can have patterns of color, but we can also have patterns of shape and other things. But in order to be a tessellation, they can't have gaps. So,
well, also, I mean, even if you look at these panels, forget about this door here, but if this was to keep going, that would be a tessellation. Like, just repeating shapes, and also there's no gaps.
What about like a sidewalk?
Definitely.
Even though it ends, it would still be considered.
Yeah, I mean, if the sidewalk was to keep
section.
going, but even if you take a section, yeah, that's definitely a tessellation.
The yellow brick road.
The yellow brick road, that would be a tessellation. So, we have a video. Yay.
you want me to click it in?
Yeah, just go back inside. It's on a link. I dragged it. It's really exciting.
Where do you get the pictures from?
You're famous! We figured we'd keep the trend going.
Google.
Yeah, you're all over Google.
Why won't it let me copy?
It controls C.
Copies. Does that work?
It's like the first observation line.
Yeah.
Maybe go to file copy.
I was like, are you serious?
This is how you do that.
Try control.
Oh, very good.
What? Text me without the text. My mom was like, no man.
This is a video about
We
tessellation.
are all around us.
Oh yeah?
We are surrounded by patterns in nature. We even mimic nature by creating our own patterns. Tessellations are one such pattern. A tessellation is created by covering a surface with interlocking figures. The finished product has no overlaps and no gaps. It is the simplest type of jigsaw puzzle. All the pieces are the same. Some tessellations repeat one shape. Others repeat two shapes or more. It's easy to create your own tessellation. First, gather your supplies. An index card, scissors, pencil, large paper, and colors such as crayons or markers. To create a simple shape to tessellate, you can cut into the left side of a square. Move the shape and slide or translate it straight across to the right side of the square.